Hello and welcome to Chapter 1, Section 8. This is all about interpreting the graphs of functions. So we're going to be looking at different graph images and understanding what we're looking at. We'll be able to describe them in a few different ways using the rules that we are coming to understand all about graphs. So we'll look at some intercepts, we'll look at some symmetry, and we'll look at things like positive and negative parts of our graphs, increasing and decreasing behavior, some things called extrema, and also in behavior. So these terms are going to be important. We'll look at y and x intercepts. An intercept, if we remember, is just wherever our graph crosses that axis. So the x-intercept is where our graph crosses the x-axis. The y-intercept is where our graph crosses the y-axis. So we'll look at some line symmetry where our values are positive and negative. We'll look at where our graph is increasing and decreasing. We'll also see some extrema, which are maximum and minimums in our graph, what you see there. And we'll also look at end behavior. So how does a graph end, going up to the left or up to the right, and vice versa. So our first example, don't worry about writing the words, but we do need to discuss it so you understand what we're talking about. What you do need to do is draw a mini sketch of our graph here so that you can have that written down, and then when we write what's happening, you can look back and understand the behavior of what you're describing. So to look at this problem, example 1 says the graph shows the cost at a community college, which is given by our y variable on the y-axis. It's a function of the number of credit hours taken. So in other words, the more credit hours you take in college, the more it costs, as you see with the rising line. We're asked to identify the function as linear or nonlinear. So we want to know, is it linear or nonlinear? In other words, is our graph a line or is it not a line? So we can estimate and interpret the intercepts of the graph as well. So where does it cross the y-axis? At what value? At what value does it cross the x-axis? So try to draw yourself a little sketch as we move forward to understand the questions being asked here. So first, is it linear or nonlinear? Well, since the graph is a straight line, the graph is linear. So what you need to make sure you write is linear. Our graph is definitely a straight line. Now, about the intercepts, we know the graph intersects the y-axis at about 0.55. So if we look real quick, at when x is 0, y is about 55, or you could also say 50, that's close enough. So 50 or 55, close to that, is our y-intercept, where this line crosses the y-axis. Notice there is no x-intercept. It never crosses the x-axis. So for that one, there's no value that we can describe. So we know it's linear. We wrote that. The y-intercept is about at 50. So you need to have y-intercept is about 50. That part you should write. We also need to know that this means there is an additional fee of $50 added to the cost charged per credit hour. That's why the y-intercept is at 50, meaning that the minimum it'll cost you to take a college class is $50. Even if you're at 0 credit hours, it still costs you $50 because they have some kind of fee associated with that. So what you need to make sure you have is the y-intercept is 50 and the graph is linear. Those two things for example 1. Hopefully you have the picture down as well, so you can reflect on that at your leisure. As we said before, there is no x-intercept, so don't worry about writing that. There's no value for our x-intercept because our line never crossed our horizontal axis. Okay, so let's call this one, this should be 1b in your notes, 1b. Okay, so the graph shows the revenue. Again, make sure we're copying the graph. So you want to draw some kind of a sketch of this so we have a picture to look back on. Don't worry about the words. So our y-axis is revenue, how much money we're making. Our x-axis is the price per unit. We want to know, is it linear or nonlinear? So that's one thing we need to say. We can also estimate the intercepts. So where does it cross each axis, the y-axis and the x-axis, for our function? So let's first determine, okay, this is a curve, and a curve we know is nonlinear. So we see A, B, C, and D are all nonlinear, so that doesn't even eliminate anything. But we've done the first part. Now we need to look at the intercepts. So where does this curve intersect the y-axis? Well, my y-axis is right here. And my curve intersects at this point right here, which is halfway between 240 and 0. So that looks like it's about 120, or close to 100. So at about 100, my graph intersects the y-axis. So that's the point 0, 100. So anything that doesn't have 0, 100 is wrong. So B should be out, C should be out. So we've got A and D. My x-axis, where does it cross the horizontal? A little bit more than 60. So that's the point 62, 0. When x is 62, y is 0. And let's see which one has that. Well, this one, A and D both have 62, 0, so those are good. Now we have to think about the revenue, though. So if the price per unit is $62 and we're at 0, so the revenue at this point is 0. That means when the price per unit is over $60, our revenue is 0. We're making no money. So the expected revenue should be 0. In other words, there is no expected revenue when the price is $62 per unit. So our answer should be D, and we can check that as we go forward. And there it is. So what you should have is that it's nonlinear. So we know our graph is nonlinear. You can write that. And our x-intercept is 62, 0. Our y-intercept was 0, 100. Those three things you need to have down. So just to reinforce, our y-intercept was 0, 100. Our x-intercept, 62, 0. Okay, example 2. Make sure the first thing you do is start copying the graph. So you want to make a rough sketch of this graph. Try to get the units semi-close. And we'll look at our y value is the cost. Our x value is the number of units. We're asked to describe and interpret any symmetry that we might see. So where in our graph does it look symmetrical? Well, I know I can imagine in this graph drawing a perfectly vertical line down the middle of this graph. And you can see that we have the same thing on the left, on the right, and the right for this line. So it's perfectly symmetrical about this vertical line here. So we can describe that. We can say the right half of the graph is the mirror image of the left half at the line x equals 30. So if I redraw that line again, this is a vertical line. Vertical line right here. And where is this line? It's at the value 30 for x, in between 20 and 40. So this is the line x equals 30. So at that line, we see it's perfectly symmetrical on the left and on the right. And that's all we have to talk about for this problem. The symmetry is about the line x equals 30. Remember, anytime you see x equals, that's going to be a vertical line. X equals is a vertical line for whatever point you're given. So this one should be if we look, we'll call this one 2b. 2b, just to make sure. We want to describe any symmetry here. So again, draw a little sketch of our graph here. And now we can look at the available options and see what is true. So, is there no symmetry? Is the right half the mirror image of the left about the line y equals 1000? Well, I know y equals is going to be a horizontal line, so that doesn't make any sense. X equals 3 would be way over here. That doesn't make sense. And x equals 30 is pretty close to the middle, so that one is a possibility. So let's look at what our solution is here. And you see that it is about the line x equals 30. It's very close to being perfectly symmetrical. And we know at that line, the revenue at a price of n more or n less than $30 per unit would be the same. So about this line, we see it's pretty close to being perfectly symmetrical. So at this line where x is 30, we see its symmetry on the left and the right side for our parabola. So what you need to say is, where is the symmetry? The symmetry is about x equals 30. So you can just say symmetry at x equals 30. And then try to draw that line going through your graph. If you label the 30 in the middle, that's golden. That's what you should do for that example. Okay, so now these are the main rules we need to know to understand this section. So first, the first way we can describe a graph is positive or negative. Positive meaning above the x-axis, and negative meaning below the x-axis. So it's positive where it's above our horizontal axis. Notice the blue. And it's negative everywhere it's below the x-axis. Notice the red. So positive and negative is one way we can describe. That's pretty simple. Above the line, positive. Below the line, negative. A second way we can describe is increasing or decreasing. So the graph is increasing where the graph goes up and decreasing when the graph goes down when viewed from left to right. So if I start my cursor on the left and move down towards the right of my graph, you see my mouse is going down as I track from left to right. That means this is decreasing from left to right. Now at this point you see it changes. If I'm still tracking the graph from left to right, now I'm rising again. So it's increasing, increasing, increasing. That's where the blue comes in. Now as I continue to track the graph from left to right, now my cursor is going down. So it's decreasing, 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 decreasing. So this tells us about, is our graph going up or down from left to right? So she's going down and then up and then down again. It's like a roller coaster from the perspective of moving from the left side to the right side. So down, up, and then down again. Increasing and decreasing. That's the second way we can look at it. A third way to describe our graphs is with maximum and minimum values. We call these extrema, and it always represents a turning point in our graph. So they're high points and low points, and we call them either minimums or maximums. It'll be a relative minimum if it's the lowest point in a region. So no other nearby points are as low as this point. So we see from here it's decreasing, 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 and it bottoms out right here. It bottoms out right here and then rises again. So that's a minimum because the points to the left and to the right of it are higher. So this is the minimum, relatively. Then we see we rise, we rise, we rise. We reach a maximum value. Then we fall, we fall, we fall. You see the turning point right here. This is your relative maximum value. So anytime your graph turns, you're going to have one of these. This one's a minimum because it's low. This one's a maximum because it's higher than everything else. So you're going to see minimums and maximums whenever you see a turning point in your graph. We call those extrema. Now the last way and easiest way to describe a graph is just with end behavior. So we can say as you move to the left, what happens to our graph? As we move to the right, what happens to our graph? So in this case, you would just say, as we move to the left, the graph goes up. So as we move to the left, this arrow is pointing up. This is all about where are the arrows pointing. So to the left side of our graph, it's pointing up. To the right side of our graph, it's pointing down. That's it. That's how we describe that. That's the end behavior. As our graph moves right, it drops. As our graph moves left, it rises. Done. That's all you have to say for end behavior. So if we understand those, we'll be okay with the next few examples. So again, with this one, let's just focus on the graph. Don't worry about the words. We need to copy an image close to this. And we want to talk about this deer population. So let's see what they ask us. We know the number of deers are y. Time is our x-axis, as it usually is. They ask us to talk about where is the function positive and negative. Okay. Where is it increasing and decreasing? Talk about any extrema that we might see, and the end behavior. The end behavior. So those 4 things we just discussed, we'll have to find those in this graph. So hopefully you have an image close to that so we can now describe it. So our answer shows us our graph is positive in the beginning. So if we go back, it's positive where it's above the x-axis. So it's positive this whole time. It's always above the x-axis. It's always positive. So it's never negative. So you can just say for this, our graph is always positive. It eventually would go negative, but in the picture we're given, it's always positive. Also, we see it's increasing in the beginning, then it decreases, and that describes our deer population. So it increases a bit and it decreases. So you can just say that it increases and decreases. It does both of these things. Just have that down. Now we also see a relative maximum halfway through our graph. So you saw the graph do something like this, where it rose and then it dropped again. Up here at this point, that's our relative maximum. It rises, then it reaches a point where it's the highest it'll ever be, and then it drops again. So that's a relative maximum. So just say that there was a relative maximum. That's good enough. And there was also a relative minimum very early on, right about this point in our graph. It was higher, it dropped, and then it rose again. So you can also say that there was a relative minimum as well. If you can point out where they are in your graph, like saying this is our min, that's your min, and our max is here, then that's even better because you can look back at that and really understand how you labeled it. So that would be great to have those things down for this example. You saw it was positive, it increased a bit, decreased a bit. We had a relative maximum and a relative minimum. Okay, looking at example 3. We want to draw a quick sketch for the speed of the car. So take some time to do that. And now let's look at what we're asked to do. So we need to find out the same things. Where is it positive? Where is it negative? Where is it increasing and decreasing? And where are any extrema? And we can also describe the end behavior. So looking at this graph, where is it positive? Where is it negative? So positive means above the x-axis. So our x-axis is here. Time in minutes, that's our x-axis. So where is the graph above that? Well, the whole graph that we see here is positive. It's always above until we hit about 7.5. So we can say our whole graph is positive the whole time. The whole time we see it, it's positive. In other words, the speed of the car is always positive for this example. Of course, it doesn't make sense that the speed of your car could be negative because that's just not realistic. That makes no sense. It can be 0, it can't be negative. So the speed is always positive. We saw that. Let's talk about, is it increasing or decreasing? Well, we see it increases here. It's rising, rising, rising. It's dropping, dropping, dropping. Rising again, dropping again. So we see there's a pattern of back and forth. Increase, decrease, increase, decrease. Any extrema? Well, every time the graph curves, we're going to get something. So here's one. Here's another one. And here's a third one. So let's think about, are these maximum or minimum? Well, this definitely represents a maximum value. That's a max. because everything around it is lower, so that's a maximum. This one we see it's dropping, then it hits a bottoms out, and then it rises again. So this must be a minimum. And then here we see another maximum. Everything else around it is low. This is the high point. So these are relative maxes, and here's a relative minimum. For this example, the end behavior, well, it's dropping. To the left, it's dropping, and to the right, it's also dropping. So that's how you could describe those. So if we look at potential answers, which one describes what we just said? It would be option B here. Don't worry about writing all these specifics. If you label the graph as I had just labeled it, that is perfect enough for this example. We saw where it was positive, negative, increasing and decreasing, and we labeled some max and min. So if you can understand that, you're good for this section. We'll get into our assignment and get as much done as we can so we can limit the amount of work we have to do over the weekend. So, without any further ado, let's get started.